Right, in this session we'll discuss Fajans rule. What is the use of this Fajans rule? We decide the character of covalent character. So 100% pure ionic compound is not there, and 100% pure covalent compounds is not there. So it is a mixture of covalent nature and ionic nature both having. So we decide which is having more a covalent character or ionic character. We decide based on the Fajans rule. So what are the rules they are giving in the Fajan? Let me explain now. Right here, the first one is here, high polarizing power cation or anion is directly proportional to covalent character. So what is that here? Exact meaning, the polarizing power is more, the covalent character is more. So that cation and anion. When cation having more polarizing power, the small size and high charge, small size high charge cations having high polarizing power, and anion is here high charge at the same time large size. So large size and high charge anion is more polarizing power, so such ions having more covalent character. So I hope it is clear this point. The polarizing power directly proportional to covalent character. So the cation when having high polarizing power, small size and high charge, and anion having high charge and large size, in this case having high polarizing power. And this is only second point, the small size cation and high charge cation more polarizing power, already we discussed, and more covalent in character. Large anion having high polarizing power, this is already we discussed, right? I hope it's clear this Fajans rule here, right? See in the next slide. So I given here when it is ionic character, the simple trick we have to remember, ionic character which condition is more, and covalent character which condition is more. So ionic character here, low positive charge, okay, and large cation and small anion, exactly opposite, high positive charge, small cation, large anion. So these condition we decide the ionic character and covalent character, right here. Let us see the few example. So the cation is same, but anion is here iodine and bromine and chlorine and fluorine, which is having more size. Here iodine is more size, so iodine is large size anion containing more covalent character. So this is the order, this is the increasing order of covalent character. So Ki having high covalent character, right? And then here one more simple trick I will tell to you, which is more soluble in water. So polar molecule, that is ionic compounds are soluble in water is more, covalent compounds are less soluble. So solubility is here top to bottom, here decreases because of it is more covalent character. So I hope it is clear, right? Next one here, the anion. So here the anion is same, okay, and cation, what happened here, the cation size is increases. So small cation is high covalent character. So here lithium is small, so this is the order. So I hope it is clear, this is the covalent character order, right? See in next slide few more example we will see here, we can understand very clearly. So here and third example, here having +4 charge, the tin having +4, and here +2. So charge is more, covalent character also more. So this is covalent character order, right? I hope it is clear, covalent character. And next one, charge and cation and anion and increases, and covalent character also increases. For example, we are taking charge on cation in this example. Right here, what is the charge having sodium? +1, here +2, here +3, and here, so the charge on cation increases, covalent character is increases. So this is the covalent character order. And next one, charge on anion. So here -1, and here -2, and here -3. So which is having more charge? So this is the having more charge. So charge increases, covalent character also increases. So this is the order of covalent character. So exceptionally here, okay, we will discuss in the fourth point. Then we will get clear idea about this exception. Right? So binary compounds, AB type compound like NaCl, like this. Okay, binary compounds. So electronegativity difference between the A and B, electronegativity difference A and B, it is equal to 1.7. It is equal to 1.7. The electronegativity difference, A and some having electronegativity and B having some electronegativity. You can do the your subtracting. That value is equal to 1.7. In such a compound, it is having 50% of ionic character. Okay, in the condition, the 50% of ionic character. Okay, if you electronegativity, the difference is less than 1.7, less than 1.7. So in that case, it is having covalent character. If the electronegativity difference is more than 1.7, it is ionic character. So like this, in this case also we can decide the which is having ionic character, which is having covalent character, which is having is equally based on the electronegativity factor also. But here one exception is there. The electronegativity is greater than 1.7, but till it is covalent character, right? Actually here the greater than 7, okay, more than 7, it is having means what character we have? Ionic character. But it is HF having greater than 7, 1.7, the electronegativity difference, but it is still covalent character. It is the one of the exception of in this Fajans rule, right? I hope it is clear. So in one more factor also is there. We decide the covalent character, right? The covalent character is more cation with the pseudo noble gas electronic configuration. So the pseudo noble electronic configuration nothing but N-1 into D10 and 6p6 and S2 as compared to the NS2 and NP6. So here this configuration, pseudo electronic configuration, and having more covalent character than compared to the general noble gas configuration. The example here, the copper having the electronic configuration here 3s2 and p6d10. So it is copper, and we know that sodium here and 1s2 2s2 and 2s2 2p6. So this is having a less covalent character. So this is the order of covalent character. I hope it is clear. This is regarding information about the Fajans rule, right?